Our problem is a counterflow shell and tube heat exchanger has hot fluid entering at 200 degrees Fahrenheit and leaving at 140 degrees Fahrenheit. Cold fluid enters at 70 degrees Fahrenheit and leaves at 110 degrees Fahrenheit. The log mean temperature difference is most nearly 60 degrees Fahrenheit, 70 degrees Fahrenheit, 80 degrees Fahrenheit, or 100 degrees Fahrenheit. Let's visualize the flow in a schematic diagram. Here is the heat exchanger. Hot fluid flows on the top in the shell, and cold fluid flows in the opposite direction in the tubes at the bottom. We'll mark the inlet and outlet temperatures for each fluid. First, we compute delta T1 equals TH inlet minus TC outlet equals 200 minus 110 equals 90 degrees Fahrenheit. Next, delta T2 equals TH outlet minus TC inlet equals 140 minus 70 equals 70 degrees Fahrenheit. Now we use the log mean temperature difference formula. Log mean temperature difference equals delta T1 minus delta T2 divided by the natural logarithm of delta T1 over delta T2. Substitute the values. Delta T1 is 90 and delta T2 is 70. Let's compute the numerator and the denominator. Numerator is 90 minus 70 equals 20. Denominator is the natural logarithm of 90 over 70, which is the natural logarithm of approximately 1.286, equals about 0.2513. Dividing 20 by 0.2513 gives approximately 79.6 degrees Fahrenheit, which rounds to 80 degrees Fahrenheit. Therefore, the closest choice is option C, 80 degrees Fahrenheit. Reference: NCEES Handbook Section 5 on Heat Transfer, Log Mean Temperature Difference.